Okay, let's look at 11 and 12 on that old final exam. So here's the setup for 11. April bought 6 burgers and 2 slices of pizza from a restaurant, and it cost $38. May bought 3 burgers and 4 slices of pizza for $31, and we're supposed to find out how much a burger costs and how much a slice of pizza costs. So let's start out by choosing our variables. The things that we don't know that we want to know are the price of a burger, let's call that B for burger, and also we don't know the price of a slice of pizza. We don't know that, let's call it P for pizza. I'll try to keep it so that my B's and my P's look different. So each of these facts, each of these things that people ordered are going to turn into an equation. So if we look at what April bought, 6 burgers and 2 pieces of pizza, how much did she spend? Well, total she spent $38. But there's another way we can write down how much she spent. If a burger costs B dollars and she bought 6 burgers, then the total she spent on burgers is 6B. And for pizza, if she bought 2 slices of pizza at P dollars per slice, then the total amount she spent on pizza is 2P. So the total amount that she spent is everything on burgers plus everything on pizza, so we can just add these. So on the one hand, the amount she spent is 6B plus 2P, and on the other hand, it's $38. So those two things must be equal because they're both the total amount she spent. Okay, when we do the same thing for May, we get 3B plus 4P equals 31. And so this is our system of equations. We need to solve this system of equations. Because of the form that the equations are in, it looks like we could solve this easily using elimination. You could use substitution if you want to, but I'm going to use elimination because that's what I feel like doing. So it looks like if we multiply this second equation by -2, then we'll have it set up for the b's to eliminate. So that gives us, that makes this second equation, I'll cross it out so that we don't actually get it mixed up. So it makes the second equation -6b minus 8p equals -62. All right, now we need to add these two equations together, these two equations. So we'll add those together. The b's cancel, which is good. The whole point was that the b's cancel. 2p minus 8p, that's -6p equals, and then on the right-hand side, 38 minus 62, that's -24. All right, now we're almost done. Let's move this up here. We're almost done solving for P. We just need to divide both sides by -6. So -6p equals -24. We'll divide both sides by -6. We get P equals 4. All right, so now we know the price of a piece of pizza. A piece of pizza costs $4. Now we need to go back and find the price of a burger. So we'll use one of the original equations. One of the original equations was 3b plus 4p equals 31. So we'll put our value for p in there. We get 3b plus 4 times p, which we now know is 4, equals 31. And then we can solve this for b. We get 3b equals, 3b plus 16 equals 31. Subtract 16 from both sides. 3b equals 15. Divide both sides by 3. B is 5. So a burger costs $5. So pizza is $4. And a burger is $5. Okay, let's move on to number 12. Okay, lots of parts to number 12. So here's part A. Simplify this, x to the third times x to the fifth. There are two ways to do this. Sort of the way that just uses what these exponents mean, and then there's sort of a shortcut way if you happen to remember some laws of exponents. So the first way, x to the third is actually x times x times x. And then x to the fifth, that's x times x times x times x times x. And if you put all of these together, there's 1, 2, 3, 4, 5, 6, 7, 8 copies of x all added together. So that's x to the 8th. The other way to do this one is if you happen to remember some exponent laws. One of the exponent laws says when you have the same base and it's multiplied, you can add the exponents. In other words, x to the third times x to the fifth is the same thing as x to the 3 plus 8, but 3 plus 8, sorry, not 8, how about 5? So x to the 3 plus 5, but 3 plus 5 is 8. So either way, you get x to the 8th. All right, on B, part B, so simplify 3y squared over 9y to the 4th. Again, we can do this just by expanding the powers, or we can use some laws of exponents. So if we expand the powers, this fraction looks like 3 times y, and in the denominator, 9 times y times y times y times y. Now we can start canceling things. So this y cancels that y, this y cancels that y, this 3 makes this 9 a 3. In the numerator, there's nothing left over, so it's really a 1. And in the denominator, there's 3 times y, that's 3y squared. Just like in the last one, there is a shortcut if you know your laws of exponents. The shortcut is you can cancel this 2 of these with 2 of those. That leaves 2 y's behind. And then cancel a 3, and that leaves behind a 3 down there. And you still get 1 over 3y squared. All right, same thing either way. All right, let's look at part C. So again, there are 2 ways to do this. If you just want to expand all of the powers, this is negative 3 times, and now it's 3 copies of a to the 4th. Notice that the exponent 3 here does not apply to the negative 3, only to the stuff in parentheses. That's the order of operations. So negative 3 times a to the 4th times a to the 4th times a to the 4th. So this is negative 3 times, and now we can use that law of exponents I mentioned a minute ago. Since these parts have the same base and they're multiplied, we can add these exponents up. So 4 plus 4 plus 4, that's 12. So a to the 12th. There's another law of exponents that makes this even shorter though. And here it is. So this is negative 3 times a to the. Now when you have an exponent and then in parentheses another exponent, you can actually multiply these exponents. So this is a to the 4 times 3, and 4 times 3 is 12. So again, you get the same thing either way. All right, last one. As usual, we can expand the powers, or we can use exponent laws. if we just expand this, so raise this to the third power, that's 2m squared times n times 2m squared times n times 2m squared times n. Now we can rearrange this product if we want. It's 2 times 2 times 2 times m squared times m squared times m squared times n times n times n. Now we can simplify this. 2 times 2 times 2, that's 8. M squared times m squared times m squared. Same base, we can add up the powers, so that's m to the 6th. And then finally, n times n times n, that's n cubed. Another way to do this is to use the power of a product exponent law, which basically says this exponent here jumps onto each piece. So this would be 2 to the third times m squared to the third times n to the third. Here, m squared to the third, we can use the exponent law we used a minute ago, and that's m to the 6th, right? 2 times 3 is 6, and then n to the third, and 2 to the third, that's 8. So either way, you get the same thing. All right, we're closing in on the end of the test. Pretty soon we'll be done. See you later.